This episode associates with our operational experience with the BFW pump. At first, I should say that unfortunately there was an explosion for BFW pump in one of the nearby plants. So we were consulted about this matter and we reached this conclusion. We're gonna, in a stepwise manner, investigate the matter, why it happened, and how it could be prevented in the future design. Here is the BFW configuration. We know that the BFW pump, the purpose of the BFW pump is to pressurize the boiler feed water and transport it to the steam drum. Since we required high amount of water with high pressure for a steam drums in a steam generation loop, these pumps are extremely critical and extremely important to every plant. And in each configuration that I have witnessed in different refineries and let's say petrochemicals, I see that we have this something like this one. It is one of the configurations for one of the metal plants. We have pump A, pump B, and pump C. Two of them are in operations and one of them is a standby. This A is driven by turbine and this B is driven by turbine and this C is driven by motor. And sometimes uh, we have a shortage of steams, then we have to use the motor instead of the pump driven by motor instead of this ones. That's the whole configuration of BFW pumps, and here you can see that uh, the suction of each of them are similar to each other. You see, this is the here is the start of the suction header. Let's call it suction header. It is distributed, you see, for each of these. And let's have a look at the discharge here. The discharge of them, you see here, their discharge like this direction, like this direction, and like these directions are connected to a header. But what is this operational experience that led to the operational mistake that led to the explosion in for one of these BFW pumps? Imagine that this pump, this pump, and pump B and pump A are in service. Now, because of some abnormalities, because of any reasons, we are supposed to put pump A out of service and put pump C in service. Notice that, please, that here you see this configuration for check valves. These are not conventional check valves. These are in fact the ARV, automatic recirculation valve. And unfortunately, these ARVs are the source of the problem. How? Let's see. When I put this pump out of service and start putting this in service, this flow passes through this ones, and since this is not pressurized, don't worry if you don't know about this once, because later in 1 minute I'm going to talk about this structure. Since it can pressurize, it can go through this one. So at first, because of the function of the ARV, it passes through this ones. And since the uh, minimum flow of each of these are connected to these ones, these directions, this flow goes into these directions. It has two choices, the here or here. It goes into two directions. In one of the direction, it goes into these directions like this and pushes the link between these inside the ARV. So the outlet is open at the moment, and when it starts pressurizing, suddenly there is a surge of flow from this side and unfortunately we this flow a portion of this flow goes into this direction, and since here at the moment is open for a moment, this flow goes to this direction, and this flow has the power to rotate the pump in a wrong direction. And since this pump is connected to a turbine, and this turbine experiencing some high temperatures, finally it led to the explosion. To get better picture of this, let's review by checking this picture and see the sequence here. This picture is the bigger picture of this ARV. Here is the inlet and here is the outlet. Turbine driven pump A is gradually put out of service. Then the operator starts putting motor driven pump in service. The return of motor driven pump is now pressurized, and since the return of pumps are connected, the high pressure BFW goes in the first driven turbine return and ARV in the wrong directions. So it pushes this rod to these directions. You see, to these directions. And when it is open, it is closed. And when it is closed, it is open. Here is the main direction for outlet, and here is the minimum flow directions. So when it closes, it becomes opens. Consequently, the rod number 1 pushes the rod number 2, and thus the high pressure BFW find its way. And when the here this high pressure, there is a surge flow of the high pressure here, it suddenly goes in this direction, and since this minimum flow was closed, this one is open and the water can pass through this line, through this way. You see, the water can easily pass through this way. And here, consequently, the pump is connected to a turbine. The turbine is rotated in the wrong direction, which finally led to the explosions. So what is the solution here? To avoid such disaster, the following have been taken to address the problems. A simple check valve at the outlet of ARV is installed for such large BFW pumps, or an anti-rotating lock is installed for pumps in the new projects. It is recommended. That's the end of this session, and I hope that this experience would be beneficial for your career in process engineering, and you wouldn't make such similar mistakes in your career. Have a good day.